Welcome to eCruz Learning because it's just that easy. With your host, Mr. Cruz, and today we're going to talk about parallel lines and perpendicular lines, okay? So this concept starts very simple and then it builds up, okay? And it becomes complex. And the reason why I just keep saying it's just that easy is not just because it's a catchphrase or whatever you want to call it, slogan or something. It's because in math and in life, really, if you have any complex problem, and you break it down into a smaller pieces, it becomes easier. So that's what we're going to do with 5.6 parallel and perpendicular lines. I'm going to start very simple. We're going to build up to be a little bit complex, and then those complex problems, we're going to break them down into smaller chunks so that it becomes easier. So here we go. The first thing we need to know, and I'm going to use white for this background. This is the easy stuff, all right? So let's do it. So right now, I want to take you back to 5th grade, okay? Hopefully you know this. If you don't know this, then please make sure you refresh yourself. Make sure you write this down. Let's say I gave you a Cartesian plane, some coordinates over here, and I give you two lines, line 1 and line 2. So I'm going to call this L1, and I'm going to call this L2. I have two different lines. What make these two lines parallel? If I ask anyone what are parallel lines, they are going to say, oh, they're lines that they never meet. Okay, so this is parallel. Please write this down, parallel, label them. Okay, these are lines that never meet, which is true. The lines that never meet, but we're talking about algebra, what does that mean? Well, what that really means is that the slope of line 1 equals the slope of line 2. The rate of change is the same, and because it's the same, they never meet. Something good to remember by is that parallel lines, okay, the word parallel has two parallel lines in it, literally, all right? The word parallel has two and then I'm going to write down lel, okay, literally, two parallel lines in it, okay? So there it is. That is actually the symbol that we use for parallel. It's like this. This is the symbol for parallel lines, okay? If I say line 1 is parallel to line 2, I will say this. I will say as an example, line 1 is parallel to line 2. That's what I will say. Okay, that's how I write it. And parallel lines have something very peculiar about them, and it's that they have the same slope. Please write this down. They have the same slope, but they have a different y-intercept. Okay, they have the same slope, but they have a different y-intercept. Because if the y-intercept was the same, then we'll be talking about the same line. Because if you have the same y-intercept and the same line, y equals mx plus b, we're talking about the same line. Okay, so that's what it is. Now, those are parallel lines. Now, let's talk about the other type of lines, which are perpendicular lines. I don't know if you remember them. All right, perpendicular lines. But what makes a line perpendicular? Let's graph them. Okay, let's graph them right here. Let's do that. Again, I have L1, and now I'm going to change the color a little bit. I have L1, but I also have L2. And L2, I'm going to graph it like this now. Okay, it doesn't really matter where they are, but I'm going to graph them like this. And what happens with L2 and L1 is that they form a 90-degree angle. I don't know if you see it right there, but that is a 90-degree angle. And it doesn't matter which side I pick, because one is 90 degree. Every single side is going to be 90 degree. Every single side over there is a 90-degree angle. So 90-degree angles are depicted by perpendicular lines, and the slope has something very interesting. If M1, let's say that the slope of M1 is A over B, okay? Because you know it's rise over run. So I'm going to write it down as A over B now, okay? The slope of M2, okay, the slope of M2, it happens, something very interesting happens. The slope of M2, or the line 2, the second line, It's the slope that it's perpendicular, and that is the sign or the symbol that we use for perpendicular. It's basically a backwards T, but it has nothing to do with the letter T and everything to do with the 90-degree angle that it forms. And the perpendicular slope is the opposite reciprocal. So this is minus B over A, and this is extremely important. This is the opposite reciprocal. This is a key word in this entire lesson. Okay, opposite reciprocal. That is the slope of a perpendicular line. So, for example, in the parallel line side, on the left side, if I tell you, oh, by the way, if the slope of line 1 is 5, okay, and then what is the slope of the second line? Well, because you know that the second line is parallel, it's the same slope, okay? But for perpendicular lines, if I tell you that the slope is, let's say, 3, okay, well, let's do 3 over 4. Let's say that it's 3 over 4, and I ask you what is the slope for the line that is perpendicular to M1. We have to use the opposite. So because that is positive, because it's a positive slope, now my slope is going to be negative. All right, and then it's not just negative, but it's the opposite reciprocal. So because it's 3 over 4, my new slope is 4 over 3. I literally flip these things. I flip them, okay? I flip them because it's the opposite reciprocal. So for that, I have to flip like I did over here. I need to flip my A over B. I will give you another quick example. Let's say that I have M1 equals just 4, positive 4. What is the opposite reciprocal? Well, because you have 4, you can write down 4 as a fraction. Hopefully you know, and I'm going to do it on the side, 4 is the same thing as 4 over 1. Therefore, my opposite reciprocal will be negative 1 over 4. Okay? If my original slope is negative, then I have to make it positive because it's always the opposite. It's always the opposite. All right, so those are the basics. That's the easy stuff. Now let's do example 1. All right, so write this down real quick. If you want to pause it, you could pause it, but I'm going to read it. So hopefully you will have enough time. If you don't, please pause the video and write the problem. You need to write the problem. Example 1 says, a line passes through 12, 5, so that's the point, and is parallel to the graph of y equals 2 over 3x minus 1. And what they want to do is write the equation of a line, okay, so the EOL, the equation of a line, in slope-intercept form. So they tell us how they want it written, all right, in slope-intercept form. And that's what we need to do. All right, so this question looks a little bit complex, but we could break it down into pieces, all right, so that it is easier. Okay, and that's what we could just say that it's just that easy, because if you have a word problem, you can break it down into 3 easy steps. The step number 1, hopefully you know by now, number 1 is what you want. Okay, it's always the same thing. Number 1 is what you want, number 2 is what you know, number 3 is what you need. It's always the same thing. You need to know this. You need to know this, especially for the EOC, because 33% of your problems are going to be word problems. So you have to make sure you know them. All right, so what do you want? You want the parallel line. You want the equation of a line. So you want the parallel line. Okay, please. You want the parallel line. Write this down. Parallel line. And you want it in slope-intercept form. They literally tell you, write the equation of a line in slope-intercept form, and they tell you that it's parallel. So therefore, you want the equation of a line, and you want it in the form y equals mx plus b. That's what you want, because that's what they're asking for. So now you need to know which form is which. Slope-intercept, meaning that you can see the slope and you can see the intercept. Remember, mathematicians are not that creative. We are pretty much straightforward. All right, so y equals mx plus b. Number 2 is what you know. By reading this problem, what do you know? Well, we know 2 things. We know a point. They tell you that the line passes through the point 12, 5. So we know the point 12, 5. We know it a point. So this is a point right there. Okay. What else do we know? Oh, we know the slope. We know the slope of the first equation, because here the whole reason why they gave you that equation that says y equals 2, 3x minus 1, you don't have to do anything with that equation of a line. The only thing you have to know is the slope, because they want the equation of a line that passes through the point 12 comma 5 and is parallel to that equation. They just keep calling random people in the background. Unbelievable. All right, so slope 1, the slope of the first equation is 2 over 3. So hopefully we know that. That's what we know. That's what we know. Okay, so now number 3 is, what do we need? What do we need? All right, so we need to put together what we want with what we know. So what do we want? We want the equation of a line. And what do we know? We know a point and a slope. Hey, we know a point and a slope. That sounds like point slope form. We could write this down using point slope form, because, well, we need the slope and the y-intercept, but we could write down, I don't know if you see it, but what we need right here is the slope, which is m, all right, and the y-intercept, which is b. That's the things I underlined. But to be able to get there, what do we know? We know a point and slope, so we need to use the EOL, the equation of a line, to find the equation of a line, and that's the point slope form. That's y minus y1 equals m, open parentheses, x minus x1. Okay, because I know a point and I know the slope, so I can substitute these things in. I have y minus, what is y1? Well, let's label this real quick. This will be x1, y1. y1 is 5, and that equals my slope, which is 2/3. So I'm just going to leave it like that, 2/3. Open parentheses, x minus, what is x1? x1 is 12. Okay, x1 is 12, and that's it. I have the equation of a line, but that is not what I want. I want the equation of a line in slope-intercept form. And that is why this is extremely important to write down what you want, so that you don't accidentally stop here. So what is it that I have to do? I have to use distributive property and then add 5 at the end. This is the last problem that we did in 5.5. Hopefully you got it. I'm not going to stop with the details. I'm just going to do it. If you have any problems with this, please go back, refer to the last problem, the last video, or come to class and ask me questions. 2/3 times x is that, 2/3 x, minus 2/3 times 12, all right, 2/3 times 12, that is just top by top, bottom by bottom, so that will be 2 times 12 is 24, and then 24 divided by 3, all right, 24 divided by 3, that's 8. Okay, so this will be 8. Another way that you could do that is do it backwards. 12 divided by 3 is 4. 4 times 2 is 8. It's up to you. And then we add 5 to both sides. We add 5 to both sides. This cancels, because what we want is y by itself. All right, and y equals 2/3 x. Negative 8 plus 5 is negative 3. And you have y equals 2/3 x minus 3. Hey, that looks like y equals mx plus b. Y equals mx plus b. So boom, we are done. That's what we wanted. That is the answer. All right, so that is the equation of a line in slope-intercept form that passes through that point 12 comma 5 and has a slope 2 over 3. All right, problem example 2. Let's do example 2. Now let's do example 2. Example 2 says, which line is perpendicular? Okay, so now we're going to use perpendicular. Please write everything down. Perpendicular to y equals 1/3 x minus 1. Okay, and passes through the point, okay, and passes through the point 2 comma 4. All right, so that is the question. Which line is perpendicular to the y equals 1/3 x minus 1 and passes through the point 2 comma 4? All right, so number 1 is what you want. So let's write that down. Number 1, what you want. What do you want? Well, you want the equation of a line. So you definitely want y equals mx plus b. Okay, you want y equals mx plus b. Remember, if they don't ask you, if they don't tell you which form, you automatically assume that it's slope-intercept form, because this is the equation of a line that we use all the time. Okay, so we want y equals mx plus b, and we want the line that it's perpendicular. Okay, perpendicular. That's what we want. Okay, so good. That's what we want. What do we know? Well, if you look at the problem, we know two things. We know we know a point, and it's right there. Okay, so we know a point. Let me write that down. Number two, what do we know? We know a point, and the point is 2 comma 4. To write down an equation of a line, we need a point and we need the slope to use the EOL. All right, the equation of a line. To write the equation of a line, because it's almost funny. All right, the EOL, which is your point slope form. We need a point and we need a slope. Okay, and what else do you know? The whole reason why they give you this equation is not to confuse you, is to actually give you the slope. Because you know that it has to be perpendicular to this slope right here. So you know that the slope of line 1 is 1 over 3. Those are the two things that you know. You don't know anything else, okay? So number 3, what do you need? So you need to put what you want and what you know together. You want an equation of a line that is perpendicular. What do you need? Well, if it's perpendicular, what do you know about the slope? You know that the slope of the second line is going to be perpendicular. So what is the slope that is perpendicular to 1/3? What is the slope that is perpendicular to 1/3? Well, you know that m1 is 1/3, and if it's perpendicular, the slope is the opposite reciprocal. So this is going to be -3 over 1. Okay, -3 over 1, which really simplifies into -3. And this is because this is the opposite, okay, opposite reciprocal, which means that you are going, if it's positive, now it's negative. Okay, if it's positive, now it's negative, and we flip them. We're flipping the 1 over 3, so now it's 3 over 1. You have to flip those numbers because it's the reciprocal. So hopefully that makes sense, and then it simplifies into -3. That's what you need, and then that's it. I'm going to go to the next page. But I'm going to write it down. Okay, you know you need to use, okay, so this is what we're going to do. Use the equation of a line, okay, in slope-intercept form. Hopefully you know what that is. That is y minus y1 equals m, open parentheses, x minus x1, because that's what you know. You know a point and you know a slope. So here we go. We know the point is 2 comma 4. So I'm going to have a y minus, well, 4, because that's y1, equals my slope. So let me back up a little bit so that I could use color code this. This is -3. Remember the point, I'm going to write it down up here, is 2 comma 4, and we use the inverse, the opposite of those numbers. Okay, and this equals my slope. My slope is the opposite reciprocal, so that's going to be -3. We just found that out. We just found that one out. Okay, what the heck? This is not y minus 3. I apologize for that. That is y minus 4, because hopefully you remember this is x and this is y. Okay, so y minus 4 equals -3, open parentheses, x, and then x1 is 2, so minus 2, and close parentheses. That is my equation of a line in point slope form. I use the point, and I use the slope that I just found, which is the slope that is perpendicular, which is -3. And then I need y equals mx plus b, though. I'm not done. So I have to solve for y, but this is the easy part. We did this in the classroom a couple of times. You have to distribute. So we're going to distribute this times this, and that times this. So not y minus 4 equals -3 times x is just -3x. -3 times -2 is going to be positive 6, so plus 6. And then we need y by itself, so we need to add 4 to both sides. We're going to use inverse operations. What I do on one side, I do with the other. And I make sure that I add it with the 6, not with the 3, because I need to combine like terms. And I end up with y equals -3x 6 plus 4 is 10, so plus 10. That is my answer because that's what I wanted. I wanted y equals mx plus b, and that's what it looks like. That's what it looks like. Hopefully this makes sense. If not, you can ask me more questions when you come into class. All right, so now let's do example 3. That will be the last one. Okay, example 3. Example 3 is very interesting because they're going to ask you what type. So this is example 3, part A. I'm going to give you two equations. I'm going to give you equation 1, which is 4y equals negative 5x plus 12. Okay, and then equation 2, I'm going to give you equation 2, which is y equals 4 over 5x, 4 over 5x minus 8. And the question is, are these lines, okay, or what the heck, are the lines, well, that's fine, are the lines parallel, okay, parallel? So I'm not gonna write the whole word. If you want to write the whole word, write it down. But parallel, perpendicular, or neither. So I'm using the actual symbols that we use to write them down, but you can actually write it out. Okay, all this means is, are the lines parallel, perpendicular, or neither? All right, so by looking at this, how do you know if something is parallel, perpendicular, or neither? Well, that was the beginning of the note. If you look at the slope, if the slope is the same, then they're parallel. If they're the inverse or the opposite reciprocal, I should say, then they're perpendicular. If it's not the same and it's not the opposite reciprocal, then they're neither. If you look at number 1, can you see a slope? Well, not really. You won't be tempted to say that it's negative 5, but it's not, because it should say y equals mx plus b, and you have a 4 in front of the y, so we actually have to divide by 4 and get that y by itself. And remember, you divide every single term by 4, just like if it was a distributive property, but we're actually dividing. Okay, so this equals negative 4 over positive 5, that's just negative 5 over 4, or negative 5 over 4, I should say, x, and then 12 divided by 4 is just plus 3. Can you see the slope from here? Yes, because this looks like y equals mx plus b. Therefore, the number in front of x over here, that's my slope. So the slope of line 1 is negative 5 over 4. The slope of line 2, can you see it by looking at it? Yes, this is already in the form y equals mx plus b, so it's 4 over 5. Are they the same number? No. Are they the opposite reciprocal? Hey, they are. One is positive and the other one is negative, so they're opposite. One is 5 over 4, and if you flip them, you get 4 over 5. So that is definitely, that is the opposite reciprocal. These are the opposite. So the slope of 1 is negative 5 over 4. The slope of line 2 is positive 4 over 5. Therefore, these are opposite. Please write this down. These are opposite reciprocal. Okay, these are the opposite reciprocal. That means they are perpendicular. So my answer will be perpendicular. These are perpendicular lines. These are perpendicular lines. These are perpendicular lines because the slope is opposite reciprocal. All right, let's do part B. Okay, let's do part B. Let's do part B right here. Example B. The first equation is going to be y equals 3 over 4x plus 7. And then the second equation that I'm going to give you, it's going to be 4x minus 3y, okay, minus 3y equals 9. And I ask the same question. Are these parallel, perpendicular, or neither? Well, can I see the slope for my first equation? Yes, this is already in y equals mx plus b, so this is my slope. Therefore, the slope of line 1 equals 3 over 4. I already have that slope. Now I have to check the slope for the second line. So now, can I figure out the slope for the second one? Hey, that looks like standard form. We need to change that to slope-intercept form. And we did this a lot when we were doing the Khan Academy, the unfair math game in class, the activity. So what you do is that you take this 4x, and you move it to the other side of the equal sign, and you change the sign. So really we have negative 3y equals negative 4x, and the 9 is positive. We're not moving it. It stays there, so plus 9. And then we need to divide by negative 3 because y is not by itself. So we have to divide every single term by negative 3, just like if it was distributive property. You get y equals, and negative divided by negative, it's a positive, so we get positive 4 over 3x. Positive divided by a negative is a negative, so this is going to be minus 9 divided by 3 is 3. So you get that y equals 4 over 3, and this is the slope. Now you can see it. The slope of the second line is 4 over 3. So the slope of my first line is 3 over 4 right here. The slope of the second line is 4 over 3 right here. What do you think it is? You might be tempted to say this is perpendicular because they are reciprocals of each other, but be careful. They are reciprocal, but they're not the opposites. They're both positive. So in reality, this is neither. All right, this is neither. And the reason is, this is kind of like a trick question, okay? Because you have the reciprocal. They are reciprocals of each other. So this is the reciprocal, but not the opposite. And in order for it to be a perpendicular line, you got to have the opposite reciprocal. So the answer is neither. Hopefully that makes sense. Let's do one more example, and this will be the last example. Example C. Okay. Remember, if I'm going too fast for you, just pause the video real quick and finish copying down things. Or repeat it. If you need to repeat it again, you can watch it twice. 6y equals negative x plus 6. That's my first equation. And my second equation is going to be y equals negative 1/6x, okay, plus 6. Okay, plus 6. Well, can I see the slope from the first equation? Not really, because I have 6y, so I have to get y by itself. Again, y equals mx plus b. So let's divide everything by positive 6. If I do that, this cancels, and I get y equals, now remember, when you have a negative x, but there's no coefficient in front of it, there's always a 1. There's always a 1. So this is really negative 1 over 6, okay, negative 1 over 6x, plus 6 divided by 6 is just 1. And from here, hopefully you can see the slope. The slope is negative 1 over 6. Okay, that's the slope of my first line. Do I have a slope for the second line? Oh, I can see it right away. It's right there. So the slope of my second line is negative 1 over 6. Look at that. They are the same slope. They're both negative 1 over 6. That means these must be parallel lines. These are parallel lines. So that's how you can identify. If you're going to try to check if it's parallel, perpendicular, or neither, the only thing you have to do is look at this slope. Okay, the slope will tell you if they're parallel, if they're perpendicular, or if they're neither. So hopefully this helps. If you have any questions, please bring them back to the classroom. This was Mr. Cruz, Any Cruz Learning, because it's just that easy.